Good afternoon, everyone. Thank you for joining us. Welcome to the webinar on modePROCON. So, modePROCON was developed under the framework of boDEREC. boDEREC was or is a project of European Union. It was funded by Interreg. So, within the framework of this boDEREC project, modePROCON, which is an decision support system or decision support tool, we have developed, and in today's webinar we will talk about different aspects of modePROCON. So first I will start with a very short presentation. I will uh, just to put the things into perspective, I will share some background information about modePROCON, why it was developed in the first place, and what was the objective, and so on and so forth. But that will not be a very lengthy part. I would say 5 to 7 minutes. Then we will start the live demonstration of modePROCON, which is basically the main part of today's webinar. And after the live demonstration, we'll just jump into live Q&A session. As Joanna already told you guys that you can join in the Q&A session. You can ask your question and maybe share your comments and so on. And at the end of our live session, hopefully if we have a few minutes, then we will just ask you to complete a survey on modePROCON. That would be really helpful, I think, for the future development. So I am today's host. My name is Sudipto Bosu. I did my Master's of Environmental Engineering at the Chair of Hydrology and River Basin Management of Technical University of Munich, TUM, in Germany. So TUM is a partner of this boDEREC project, and TUM was basically responsible for the development of the modePROCON tool. And during my master's, I was actively involved in the team which was working on the development process. I also conducted my master's thesis on this topic. So let's not just waste time on these things. Let's just jump into modePROCON and its background. So this is the outline of this short presentation. I will just give you an introduction to modePROCON and the objectives of modePROCON. And there are two key features of modePROCON, which is the estimation of the likelihood of contamination and checking the model requirements. I'll just briefly show you the theoretical perspective of those two features, but obviously the most important part is the live demonstration. So before going further to modePROCON, I would like to share, I think many of you already know, but to those who are new, I would like to share which were the main objectives of the project boDEREC-CE. So within the framework of this project, it was tried to, let me just turn on maybe my pointer. Yeah. So it was tried, the objectives were the investigation of trace substances in the environment, and also sort of literature review of the state of art of the treatment or reduction of trace elements, or PPCP, the commonly used term in this presentation would be. And another key objective of this project was to develop a tool, a decision support tool, which stakeholders can use in order to reduce in the long horizon the reduction to reduce the PPCP contamination. And obviously also at the end of the project, it is an objective of the project to propose some amendment of the existing laws and some recommendation for further research and development. So as you can see, a key objective of this project was development a decision support tool for water utilities. Actually, modePROCON is that tool which we have developed for the project boDEREC-CE. So that was actually just to put the things into perspective from how modePROCON is related to the project boDEREC-CE. So what is modePROCON? modePROCON, as I said, is a basically model-based decision-making tool for emerging contaminants. Like I said, it can also be named PPCP, emerging contaminants, or EC. So the tool is developed or designed very specifically for these emerging contaminants. And the main purpose of modePROCON is obviously guide the stakeholders, for example, water managers, towards fate and transport modeling of these chemical substances, when they should think about chemical modeling and how they can approach towards this transportation model of chemicals. modePROCON will basically guide the stakeholders there. And why modePROCON is important or relevant for this project is easily understandable that modePROCON is the tool which allows all the stakeholders to participate in the project very directly through the tool. For example, by using the tool, they can facilitate the technology of modePROCON and implement those in their study areas or their working areas, and so that improve the water condition or environmental condition in general through modePROCON. And not only just after the development of modePROCON, actually the opinions and the feedbacks of stakeholders of this project were always taken seriously throughout the development process also. It was considered while designing different features of modePROCON. So that was basically the brief introduction to modePROCON. And now just let's discuss about the objectives of modePROCON. So obviously, emerging contaminants and PPCPs are not a very common thing in the study or in the research so far. Unfortunately, the trend is rising definitely, but so creating awareness, especially in among normal people, among residents of different societies, where one objective of this project and modePROCON is designed in order to gain or fulfill that objective. Obviously, through modePROCON, we can estimate the probability to detect certain PPCPs, I mean, which PPCPs or chemicals. So PPCP is the short form of pharmaceutical and personal care products. So modePROCON helps us to sort of categorize PPCPs, which are highly risky for the environment and which are not. And obviously, it provides guidance. So which kind of parameters we need, which kind of field measurements maybe the stakeholders think about, so that they can eradicate or they can eradicate the PPCP contamination. And the end goal is obviously to mitigate the risk of human health and environment through PPCP contamination. So these were the main objectives that were kept in our mind before designing or development of modePROCON. So as I said already, so modePROCON has basically two key features, which is the one is estimation of likelihood, and the second one is the checking which parameters are required for modeling. But these are very theoretical thing. I will not go very deep into the steps by just reading the lines. I'll just show you in live just after a few minutes. But just very briefly, I would say that there are three types of aquifers: groundwater, karst aquifer, and surface water, where you can apply modePROCON. You will select that, and then you will select the chemical substances, and then you will determine the indexes. And the second, once you have selected your chemicals, basically modePROCON, depending on the chemical, can produce four types of results. And if in your case, unfortunately, or in our case, unfortunately, the result is very likely or likely to be found in water environment, then modePROCON recommends us modeling. And on the other case, if it's not likely to be found, rather is unlikely or very unlikely to be found in the water environment, then modeling is not very strictly necessary according to the modePROCON program. We'll just see this in live demonstration. So another key feature of modePROCON is also that when we need to develop a model, what kind of parameters basically we need for the development of model requirements. This has been a very critical and confusing issue for different cases. Therefore, modePROCON will also assist you, which we will also see in the live demonstration. So as I said, after the presentation and obviously after your opinions and questions, if we have time, I would like to request you to take part in this survey. I don't think we should be doing it right now because many of you maybe haven't seen the live demonstration yet. So then maybe we can come back to this slide again and just, it will take around 10 minutes. You can share your opinions and your remarks about modePROCON. So I will not further waste any time on this slide. I would like to start the modePROCON live demonstration directly. Hopefully you can see it. Just it would be great if some of you, or Joanna, could you please confirm that you can see the home page or home window of modePROCON. Can you see it?
Yes, it's okay.
All right, so we are starting the live demonstration of modePROCON, and I unfortunately, due to maybe time constraint, I couldn't show you how I have downloaded or run it, but there are tutorials on YouTube. You may already know it, but one important thing is you don't need anything. You just need a computer with a Windows operating system. You can directly sort of plug and play. You can download the program and start running. You don't need any kind of programming or anything like that. So once you have opened the modePROCON tool, you will be led to this window, which is the home page of modePROCON. You can see the boDEREC logo and the European Union logo on top of that. And on the bottom side of the page, there are 3 water systems. So as I mentioned in the presentation beforehand, that you can apply modePROCON for 3 type of water systems: groundwater system, karst aquifer system, which is a very special type of uh, groundwater system and very common in Europe especially, and obviously surface water system like for rivers and lakes. And I also mentioned it in the presentation that there are basically 2 key features of modePROCON: evaluation, which means the evaluation of the probability of contamination, and model requirements, which means that which parameters do you need in order to start or in order to conduct your modeling. So we will see both of these 2 features. We'll see the demonstration of both of these 2 features, but I don't think it's needed to do it for all type of water sources. Maybe we can just see it for one. It's exactly same for the other water systems. So I will just select surface water system. Let's select surface water system, and let's first check the evaluation, and then we'll just check the model requirements features. So I'm just simply clicking the evaluation window, and this window comes in the modePROCON program. So basically, modePROCON comes with a default database of different commonly found pharmaceuticals. So here in this default database, we have basically 115, one I just added, but normally 115 PPCPs or substances. So these are the substances which are very commonly found in the environment, or which are very commonly used in medicine or in personal care products. But I will show you later on. If you want, you can add new PPCP also, or new substance also. So obviously there's the name of the substance, and there are some other information. For example, the chemical number, the CAS number of each substance is also there in the database, and then comes the chemical properties of each substance. For example, solubility, solubility, pKa, volatility, and degradability. So why these values are here, I think many of you already know. So the way modePROCON uh, calculates the probability are based on these chemical values, which are basically done in the background of the program, which we cannot see. But these chemical values are extremely important, or so to say, the most important thing behind the calculation. Any missing value will cause a problem for the calculation. Therefore we need these values. And if you want to know about that units of this value, these are also shown in the top of this page. For example, for solubility, the unit is milligram per liter. For solubility, basically is the log KOW value, which doesn't have any unit. For the pKa, we know for pKa is also is a logarithmic value, so it doesn't have any unit. As a measurement of volatility, modePROCON uses the Henry's constant value of each substance. So this is basically the Henry's constant value of this particular substance, and the unit of Henry's constant is also given there. And as degradability, basically modePROCON shows the days that substance needs in order to get 50% degraded, so that we can also say DT50, so in days obviously. So these are 5 types of values that along with each chemical substance or emerging contaminant we need. So if you want to know more about the default database, for example, from where we have collected these values, you can easily check the reference column on the right side. And for example, here we can see that for solubility, solubility, and pKa, the source is 1. What does 1 mean? You can just check here on the reference that 1 means SciFinder. So basically, these chemical values were collected from 3 different sources: SciFinder and Comtox US EPA is a website of USA, and in that dashboard you can collect data, different chemical values, and the ECHA. So you can now easily compare the reference number. For example, in this case, also you can see the solubility, log Q, and pKa are coming from SciFinder, and Henry's constant and DT50 are coming from the Comtox US EPA dashboard. In some cases, in very few cases, I would say the values were not available. Therefore, we used a calculated value, which you can also see here. So basically, this is the database, default database with 5 chemical properties with case number and their reference source. But the number of PPCPs or emerging contaminants are unfortunately always rising. So if you have any other substance, or if you are interacting with any other substance that unfortunately is not available in the default database, you can easily add that data. And if you want to remove it, you can easily remove it later on. So technically, this database is infinitely long. You can add as many data if you want. For example, I just added one. I will add it again. I will show you how to add it. I will just delete it now. So if there's an user input data that I added, you can also delete it. But obviously, I'm just going back again, but obviously now you can say there are 115 chemicals, but the 116th one is not there. I have deleted it, but the default ones always remain there. So now I will show you that how can you easily add one substance to this database. So for example, if you click here, add new data, you will come to this page, and here you will add different details, the chemical properties of the substance that you are facing with, and that will be added to the database. So throughout our project in Italy, in the Po catchment, we faced a little bit unique chemical substance, AMPA, that was unfortunately not in the default database, but that's not a big problem because we can add it now to the database. So I'm just writing the name of that chemical substance, AMPA. I also know the case number, therefore I'm writing it, but it's not very necessary to write the case number. It's basically an optional input because as you can understand, the probability of contamination is depending on these values basically. So modePROCON needs this value basically. You cannot skip any of this value, but if you don't know the case number, you don't have to worry a lot. So the solubility value of AMPA was 146,561 milligram per liter. You don't need to write milligram per liter, but you have to ensure that the units are always same. You can also see here that solubility unit has to be milligram per liter. The degradability value was 5.47 days. You don't have to write the day. It's enough to write just the number. For sorbability, the value was minus 1.63. It's the log KOW value. For pKa, the value was 5.6. The value of Henry's constant of this particular substance was or is 0.00000015791. So that's it. These are the information that you need, the name and these 5 chemical values in order to add to the existing database. So if you don't have one, so let's just assume that we don't have the pKa, and let's try to save this, and you'll see that this data is required. So you have to add all this data. You can skip just the case number. So again, I'm writing the pKa value, which was 5.47. So now that we have all the values, I think, sorry, the pKa value was 5.6. Yeah. So now that we have all the values, now we can add it to the database. Let's click the save and exit button. And now you can see that AMPA was added to the user database. Let's check. Let's go to the bottom because the user added PPCPs are always at the bottom. Otherwise, the top 115 ones are alphabetically sorted. Yeah, here we can see that AMPA is added to the database with all the values that we have added. So that was actually all about the database. There are 115 ones, but if you want, you can easily add to the existing database. So now let's pick a few chemicals out of this database and try to evaluate the probability of contamination by those chemicals. So modePROCON allows you to select maximum 5 at a time. You can easily select less than 5, but unfortunately not more than 5. So I'm just selecting 5 chemicals. So for example, I'm selecting bisphenol B. I'm selecting caffeine, which is a very, very common chemical substance in our daily life. I'm selecting ibuprofen, which is also a very common medicine, pharmaceuticals in our daily life we take. And then I'm selecting oxypurinol. Oxypurinol was a substance that was found in a relatively high concentration in our study, in our research, which was also conducted within the framework of this project. For example, in the research conducted in Neumann Freising in Munich, city of Germany, we saw relatively high concentration of oxypurinol. So let's check that what happens, how does modePROCON talk about or suggest about oxypurinol. And I'm also selecting the PPCP or the substance, chemical substance that we added. So the user added substance can also be selected along with the default substances for the evaluation. So we have already seen the deleting, we have seen the add new data. Now you can easily click the evaluate button, and then we will see the results for these 5 chemicals. So all right, let's do it. Yeah, here you can see the results. modePROCON is showing for the 5 chemicals that we selected. It is showing the results both in tabular form and also in graphical form. So if I if I look at the table first, you can see 4 values for each chemical substance. Basically, these 4 values are called 4 indexes. So this is not the value that we saw in the database. That was the chemical value. These indexes are basically calculated by modePROCON in the background of the tool using a conceptual model, which was also developed within this framework of boDEREC project. So based on that conceptual model, using the chemical values for each chemical substance, modePROCON basically calculates 4 indexes. And based on each index, or based on the sum of the index, modePROCON at the end comes up with a result that what is the likelihood of being found that PPCP in water. So for example, here we can see for bisphenol is unlikely. That means the probability, the likelihood is not very high, in fact low. But for caffeine is very likely, the probability is very high. So for ibuprofen and oxypurinol is also likely, and for AMPA is very likely. So maybe you could remember in my presentation, I showed you that there could be 4 cases: very likely, likely, unlikely, or very unlikely. In our case, there is no very unlikely, so either is likely, very likely, or unlikely. And you can easily, you don't have to check all the indexes. You can easily understand also from the graphs. So the higher indexes means the higher tendency of being found in water. For example, we can see for caffeine, in the graph, the orange color is assigned for caffeine. And you can see for caffeine, the volatility index is quite high. The solubility index is also quite high. And the solubility index is high. So we can assume that these high indexes mean that caffeine has a very high tendency to be found in water. In our case, this was surface water. And if you see on the other hand, bisphenol B, so in case of bisphenol B, modePROCON has assigned blue color, and you can see that the indexes are quite low. Degradability index is very low. Volatility index is relatively high, but the solubility and solubility index is low, and that eventually has yielded the result that it has it is unlikely to be found in water source. So basically, this totally depends on the chemical values, and using this feature, you can easily differentiate, or you can easily sort of make a short list of chemicals about which you should be concerned of. For example, in our case, I think we should be concerned of this about these four chemicals. If you want to know more about these chemicals or substances, modePROCON also provides you a link of a literature for each PPCP or each substance. Basically, this was added by us. That's why there was no reference or literature suggestion here. But for the other four, which are coming out of the default database, there is a paper. You can click it. It's a hyperlink. The paper will be open. If you have the access, then you can read it. Otherwise, you have to buy or arrange the access. So I'm not just opening it, but let's just focus on the results. So what does it mean? Here you can see there's a line in the red color. modePROCON is saying that modeling is recommended when likelihood is very likely or likely. That means unless for the case of bisphenol, apart from this, for all the other four cases for AMPA, oxypurinol, ibuprofen, and caffeine, modeling is recommended according to modePROCON. So basically, this is the end output of the first feature of modePROCON. You know which chemicals, for which chemicals you have to develop the solute, fate, and transport model. And that was actually all about the first feature, but the modePROCON features don't end here, because whenever you need to develop a model, a question arises always that which kind of data do you need? Because in order to have a robust model, we all know that data are very crucial. So there comes the second feature of modePROCON, that it shows you the requirements for modeling, like develop a fate and transport model. So we selected surface water at the beginning, I guess. So therefore, if I click now, modePROCON will show you the requirements for surface water. But you can also go back and select other type of water sources and check what are the requirements for that particular type of water system. So obviously it will vary from water system to water system. So I don't know, let's select again maybe surface water system, and let's check what are the model requirements for surface water system according to modePROCON. So this was actually developed at our chair of hydrology and river basin management at Technical University of Munich, that using literature review and prior modeling experiences, we made a list of the parameters that you need in order to develop a model at the surface water environment. So you can easily change the size of this table, like a Excel table, and see easily the, or read easily the parameters. And for example, here we have flow velocity, water temperature, digital elevation model DEM, flow exchange with groundwater, source of contamination, initial concentration, and point of interest. So not only modePROCON is basically showing you a list of parameters, but also modePROCON is also saying you why these parameters are relevant, or why these parameters are required. So what is the application of that parameter? For example, for flow velocity, the application is it is required to calculate the travel time of a compound and to estimate the possible degradation of the contaminant. So that's why it is needed. But we can guess that in many cases, we have partially a few data and partially not. So there's always a confusion that if we can go on with this data, or do we need more data? So there, modePROCON helps you, or this is the sort of the second feature of modePROCON, that is modePROCON allows you to check whether you can develop a numerical model with your existing data. So here's, you can also select a box, like a checkbox we saw in the PPCP data window, which we used for the selection. And here we are using this box in order to indicate that we have it. So let's just assume that in the worst case situation, we don't have any of this data. So I am not selecting any of this, and I am trying to see that if a model can be built. How can I see that? I can click easily the evaluate button, and once I click the evaluate button, modePROCON will say that whether a model can be built without this data or not. So let's hit the evaluate button. And unfortunately, as you can see, that model cannot be built. Please collect the missing data. That means we have to collect the missing data. I would say that's a very is a very 1 degree solution of this problem, that at least we know that which parameters we need. But obviously there's the secondary problem, that is how can we collect this data. And here also modePROCON shows you a remark or solution that how can you collect this data. For example, for flow velocity, based on our research and experience, we have very briefly tried to express the most common way to collect those parameters. For example, for flow velocity, it can be estimated by injecting conservative tracers and measures the time taken for the tracer to travel, define distance downstream, and so on. So this will help you to sort of understand or plan your future step. Maybe you can consult with other institution, or maybe you can conduct your own sampling campaign. So that will basically that will help the stakeholders to think 1 step ahead of the problem. And once we have the data, so we can easily click it that now that we have it. So let's assume we have collected all the data, and I'm selecting all of this by clicking here. And once I am done selecting all of this data and I'm trying to hit the evaluate button, and you can see, hopefully this will be the case, that it is possible to develop a numerical model because we have all the data. Maybe if you don't have, just say number 2 and try to do the evaluate, no, it can be built. That means the number 2 data, water temperature, is also needed. So you can easily sort of check which data are needed and which are not needed. In this case, it seems like all the parameters are needed for the development of a numerical model. In case of surface water, the case or the situation will be different, or can be different for other type of model water system. We can check ourselves. But so now that we have the data, so the how to find the data, this message is totally irrelevant now. That's why modePROCON has removed that message, and it is saying that data are available, and it is suggesting that it is possible to develop a numerical model. Please communicate with any university or consultant. So that was actually the second feature of modePROCON. You can check for the particular water environment what data are needed, why those data are needed, and how you can collect those data if those are not available. We did it for surface water system. Obviously, you can do it for groundwater system. For example, here we have a relatively or a few new parameters maybe, because the situation or the condition changes the requirements of data. So but the layout and the system is exactly identical, like the way I showed you. If you don't have any parameter, you don't have to select anything. You can keep it empty and try to hit the evaluate button, and then modePROCON will say you that you need it. It cannot be built without this parameter, and it will also suggest you a very prominent or common way of finding those missing data. And once you have all those data, then you can select that and then try to uh, hit the evaluate button again. And in that case, if all the necessary data are available, then modePROCON will tell you that model can be built. It is possible to develop the numerical model. So again, you can do it for karst aquifer system. So basically, these were the key features or two main features of modePROCON. It allows you to evaluate the likelihood of contamination for a particular PPCP, and then it shows you the list of parameters which you need in order to develop a numerical model on that particular environment, and also how you can collect those missing data. So I would like to conclude my live demonstration here, and I would like you to share your remark, or if you have any question, you can ask about it, or as Joanna mentioned, you can follow her procedure to ask question about it. Thank you for your attention.
Thank you very much, Sudipto. Once again, if you want to ask a question, please raise hand using the settings of the Teams, and then I will be able to allow you to unmute yourself. Please, Giuseppe, unmute.
Thank you. Can you hear me?
Yes, thank you.
Yes, sorry, I lose the first part of the presentation, and I would have some explanation on the first PPCP database, because we have a list of pollutants, and then if we select one or more of these, then we skip to the histogram about the likely the attribute unlikely, very likely, or others are only related to the four chemical properties in the table.
Yeah, 5 chemical properties, I would
Just
say, yes.
are not linked to the monitoring campaigns.
No, so
No.
basically, it's not that modePROCON is not saying that it was collected or something like that. It doesn't have any connection with the existing the sampling campaign. So modePROCON is basically saying, from the theoretical point of view, what is the probability that this chemical can be found in the water source?
Just based on on solubility, just on this. Thank you.
Yeah.
Thank you.
Thank you for your question.
Okay, we have also Georgia. Yeah, now you should be able to unmute yourself. So please take the floor. Okay, but you have to unmute yourself. Unfortunately, I'm not able to do anything more now. Maybe you could write down in a chat your question. Okay, we will wait. Okay, there is a question in the chat. I wanted to ask in which programming language it was developed and if the end user can further develop it. And thank you for the nice presentation. Big comment.
All right, thank you for the question. So the programming language was used Python for the development. And what was the second question? If the user can develop it or anything,
Yes.
right? Yeah. No, actually, this is a sort of standalone software. So we are giving the software to the user, for example, stakeholders, so that they can use it. But yes, there's no scope of developing this software by the user, but the source code we can maybe, as a part of research, we can upload it in maybe GitHub in the internet, where other enthusiastic researchers can think about the code and they can maybe improve it or make another new application. But this application is basically a software, you can use it.
Thank you, Sudipta.
Welcome.
There is also opportunity to add additional questions. So we encourage you. Georgia also thank for the answer. Maybe you have some comments on the application of the modePROCON tool. Please feel free, but raise your hand first. Maybe in the meantime, I will admit that there's plenty of materials connecting with modePROCON, which you prepared, which you and your teams, your team family prepared within the boDEREC project. You also prepared mock, which is available on our YouTube channel. So there is a possibility to dig more into the application of the modePROCON tool. There will be also a demonstration video which was presented among stakeholders during the stakeholders workshop, and the demonstration video will be available on the YouTube, but we still wait for translation, and we will provide also subtitles in 7 national languages, in 5 national languages basically. 3 of our country participating in the project country use the same language, so 5 national languages will be provided. The subtitles will be provided, so please check out our YouTube channel. The demonstration video should be available soon.
Yes, and if any stakeholder faces difficulty while installing or running the modePROCON, you can also find tutorial about that in the YouTube channel of boDEREC-CE. As Johanna mentioned, in the MOOC course, there is a demonstration of the installment, which I skipped in this part, but you can find it easily in YouTube. It's, I think, open source, anyone can watch it.
Yes, exactly.
Mhm.
Okay, so Sudipto, I think we would not get any other question. So you mentioned about feedback on modePROCON.
Yeah,
so
yeah.
maybe,
Yeah, I can go. I think I can close the modePROCON and turn on the survey. But before going to survey, I would like to say one more thing. So those who are interested about the background model, how did modePROCON calculate those indexes? You can also find that in the MOOC course. There it is discussed more elaborately what was the chemical concept behind the calculation. I think I can also, if I have a couple of minutes, Johan, I can also show maybe a little bit about one project also, which was done, one case study, which was also done under the project of boDEREC. That was actually in Freising, Neukölln in Munich. And just a very quick go through it. I will take just 2 minutes just to put the things into perspective, how modePROCON is applied or can be applied in the real life. So this is actually the partner universities of boDEREC project, like Joanna mentioned, and also these were the case studies where all those researches or sampling campaigns were done all over the Central Europe. I would say 7 countries, I guess, Poland, Italy, Germany, and Slovenia, Germany, Czech, and Austria, Croatia, for 3 different type of water aquifers. As that's why modePROCON had also 3 features. I mean 3 type of aquifers. And in case of the case study that was conducted by TUM, it was in Neukölln in Munich. This was the area around 20 square kilometers. This was deliberately selected because it was very close to a wastewater treatment plant. And there we also, this was the geography of that aquifer. This was for groundwater. And we did the sampling campaign in different locations around this area, and found a list of chemicals which were found in high concentration. And just for the sake of comparison or to understand the situation, we also used those chemicals in the modePROCON. Like the question came that did we use the data? No, we just used the name of these chemicals and try to see what modePROCON say. And the results of modePROCON were also, I would say, similar. You can see high indexes. The indexes were quite high. That means according to the modePROCON theoretical point of view, these PPCPs or these substances can be found in water sources. And to be honest, this was more or less in the situation also in the our case study. So in the future, we can say that we can sort of that reverse the engineering process. We can use modePROCON at the beginning and then make a list of chemicals, and then maybe we can also think about the modeling of those chemicals. So this is basically the idea of modePROCON. Thank you again. I think this barcode should work. So it would be really help for us if you could just scan the barcode using your phone, or otherwise, I think I can also paste the link in the chat, right, Yona? Then it will be
Yes,
easy
yes,
for
please.
those, yeah, those who
If
are.
you will be able to paste it in the chat, it will be
Yeah,
perfect.
I think I can do it. So this is the link, and so the chat is here. It's a Google form survey. You don't have to write your name or anything. So it's an anonymous service. You have to just share the opinion about modePROCON, what did you think? How did you understand it? To be honest, the demonstration was really fast due to the time constraint, but I think still your opinions or comments would help us in future.
Okay, so many thanks, Sudipto, for your great presentation. Thank you for sharing us your knowledge, your experience, and your findings in establishing the modePROCON tool. I hope all of the participants are also content for the presentation. I would also ask all participants to fill in the feedback form which is connected with the event, and just put it on the chat. So please also share with us your feedback about the meeting. I don't know if you want to add something, Sudipto.
No, I would like to just thank you for organizing this, and thanks everyone of the project who helped us while developing the tool.
Okay, so thank you very much. I think we can finish now. Thank you very much.
Thank
Thank you
you.
for your participation, and thank you for your presentation, of course.
You're welcome. Have a nice evening. Bye.
Have a nice evening. Bye bye.